Welcome everyone to a special Performance Clinic. It's part of my Cloud Automation Unlimited season. Today I have Thomas Rothschaedl. Servus, Thomas.
Hello.
Hi.
Andy, servus.
Hey, thank you so much for doing a version-aware distributed trace equals PurePath analysis. I added the PurePath because we've been talking about PurePath for the last at least 15 years that I'm here. We've been doing distributed tracing for a long, long time.
Definitely, yeah.
But distributed tracing seems to be the hot word, obviously, these days. That's why we want to make sure we show our users and those that want to become Dynatrace users how to do distributed trace analysis. We call it PurePath, version aware. And what that really means, I want to hand it over to you.
Exactly.
Enlighten us.
Thank you, Andy. Yeah. So, yeah, we call our PurePath also, I heard it internally sometimes as distributed traces on steroids, as we have much more information on it. And yeah, what I want to show today is a little bit, at first, a refresher. I think you know it already. We have release management out there. And basically, we use the same information also on our distributed traces in a completely automated way to ease the analysis here. But to enable the audience here to get started, we want to do this refresher here and explain also how we detect all these different versions. And then we jump directly to several demos.
Perfect.
Yeah, so a quick overview about the release monitoring here. So what is it and why we use it? So the most important thing is that we allow our customers to keep an oversight about their releases. So which versions are deployed out there. We have quite big customers that have continuous deployment. They have sometimes, we also different versions in parallel running, and our release management help the clients to keep the overview there and understand also if specific problems are just related with specific releases or if these are problems over the top. I have also added in the last slide some resources where I have a link to the Performance Clinic if someone is interested here. But versions are also important to track service level objectives and they can also be used to quickly react on problems, and also you can do this with Dynatrace with auto-remediation. So therefore, we have several information out there, also some performance clinics are there. And what we want to focus today is how these versions can be proactively used to diagnose specific versions. So to understand on a transactional level, so on a distributed tracing level, if there are any changes in behavior for transactions that should look similar in the environment. Also, this can be then used in an aggregated way. So we'll also show how we do this in Dynatrace from our own environment and how you can use it then later on in any example environment here.
Maybe one point I want to add to this.
Yeah.
What I love about this screen is we at Dynatrace, we have different tools that we use to deploy in different environments. So do our customers. That means we still use some Jenkins, we use some Argo, we use some Captain. We use different types of tools to deploy in certain environments. Therefore, every tool kind of knows what they've deployed, but only Dynatrace knows what is deployed where in which version by which tool. So this is the great thing of having really the overview of what is really running in your environment and where do you have problems.
Very good point. Very good point. Yeah. So when we go now deeper and talk about analysis of your distributed traces in Dynatrace, it's quite easy to get started. So when you follow the setup for our general release management, you also get it in Dynatrace. So basically, we use the Dynatrace release version and the Dynatrace release build version and put it automatically on the distributed traces that are collected by the one agent. Also release stage and release product are important there to put there. They are right now not considered in the distributed traces on the PurePath by Dynatrace. So it's quite simple. In an environment where you run either on Linux or on Windows, when you export the DT release version, specific version, or set DT release version, it's out there. But as you know, most of our clients, or we see them running their versions in Kubernetes. And here we have an easy possibility because there we automatically use the Kubernetes labels there. But what is important in this specific case to have this version also available on the traces, it's important to export this environment variable there, that it's available for the agents that are monitoring your services. And here you have a nice example how you can basically link to the version of your Kubernetes label here, that the same is used here for the environment version. We want to basically avoid code duplication here. So that's quite nice here. You can also then add, in my case, I had also the release build version here explicitly there, which is typically a release date or timestamp or something like that.
I think this is very important because I've worked with Kubernetes now for a year, maybe 2 years. And the reason why this is so interesting, because on the one side, on the top, the labels, this is metadata for Kubernetes itself, right? Description of, in this case, the deployment. Everything that is under the container section is really what goes into that container that runs your app. This is stuff that actually ends up on the process that then our one agent can pull out. And when we are capturing distributed traces, our PurePaths, we can then say, hey, did you release version? We attach it to every single PurePath. And I think I actually updated recently all of my examples that I use with the value from the field reference, because I think you pointed me out to this. This is really nice. Yeah, it makes it very convenient.
To have this here, and then you have just one time and avoid some confusion here. So here, where are these versions that you have set up here are reflected in Dynatrace? So here, when we look at our atomic component, let's call it in that way, that this single distributed trace, you will instantly see it for a specific microservice, because here, as you know, a distributed trace can go across multiple microservices. But here, we are, for instance, in a specific service that is called add service. And when you open here the metadata field, you will see exactly the information is provided via the environment variable here, or the build version here. So we made it very prominent also here in this when you extend it here, but also on the details perspective, PurePath details perspective, where you can see all the information that our Dynatrace one agent collects out of the box. They are there with quite a lot of additional information, like here we see that the specific endpoint here is a gRPC service, and we have here the release version and the build version again on it.
So, but just to clarify again, on the left, we see an end-to-end distributed trace that starts in Go, goes over ASP.NET, back into some other components, back into .NET, some Python. That means these are all individual spans of the end-to-end distributed trace, everything captured by Dynatrace. And on every single span, we are pulling out the version information from the process. So we really know exactly how this transaction was executed by which version on every step along the way.
Yeah, exactly. So because this can be multiple servers that are running in completely different versions here, it's quite likely there usually. Yeah. But having it on a single span is quite nice. It's also quite cumbersome to understand what is happening, because you can have luck to have some really representative distributed trace across the environment, or so that's why we recommend doing this analysis in aggregated way, because then you really understand and can see what is going wrong, is everything right. And therefore, I have now prepared some examples that I took screenshots from our pre-prod environment of ourselves. So this is a pre-prod environment where we regularly usually here has sometimes several times a day is typically new releases being tested there, some load tests are there, or developers just click around to see if everything is working here. And here you can, basically I made a link here from our multidimensional analyzers. For the newcomers in Dynatrace, you can access them by clicking to the multidimensional analyzers. This basically allows you to do analysis of all your distributed traces in your environment. You can either create a new view here that is completely empty. You can start with some predefined views, like getting an overview about the top web requests, database statements, or exceptions analysis, or do something that I have done before. I have prepared here some analysis views. And the first one that I want to jump in is just to get an overview about the requests per version. So to understand how the requests distribute across the different deployed versions out there, which per se can be already quite interesting to understand. Do I have some times where I have multiple versions in parallel deployed to see what is the load that is the load equally distributed between the servers out there, or is now really the latest version replacing the older versions and are all the fading out here.
And this is really nice. I mean, this is a perfect example of a rolling update, right? It seems every couple of hours you have a rolling update of a new version.
Exactly.
Yeah. And last question, I see you've split by 2 dimensions. You're using the release version and the build version. So kind of the major, minor, but it's the chart will then show you they combined split by?
Exactly. So we see here, for instance, our application release versions is usually the sprint number here in the beginning. So it will be for always our sprints 126. And then we have, it's a timestamp here, which is then basically the build version.
That's pretty nice.
And we see here the request count across of them, and that's quite nice. So here in that case, I made it quite simple. What you can also use, and I have it later in the examples, you can also add here some text to make this more readable for the users here. But in our case, this is readable for our development team because they know exactly when they see these numbers, what is it about. And what I did before, basically, I was clicking on the Save button on the top right, and this allows you to save such analysis perspective for your convenience to get access to it quite simple by yourself, or you can also make it available for your colleagues. It's quite convenient in our environment. We have quite a lot of developers in the meantime, and so we can easily share them. Yeah,
especially you have some performance experts, some SREs, they create the views that they want to see for all the different applications.
Exactly. Yeah. What is always possible also on all of the screens is just share the link in the URL.
Yeah.
That's also quite helpful here. And when you below the Save button, there is a Create Metric button. Because what you need to consider here, these analyzes are running on the analyzed distributed traces of your environment. So we basically work here on the real data that is collected there. It's, as you can guess, quite a high number of data. We have here a few million requests here at this time frames here. And to persist a specific analysis perspective, we allow to store them as a metric to make them available over a longer period of time. You can access them via API, you can set up alerts if you want to, and so on. And all metrics that are saved there are automatically then considered by the Davis AI.
Cool. So you start with an ad hoc analysis like the multidimensional, you figure out what you want to see. And then if you say, hey, this is something I want to either alert on, I want to query this data through the API, then create a metric for it.
Perfect, exactly. Yeah. And you can also put it on dashboard. I will show this later on because that's quite convenient also for navigation later on. But I will show this then in the demo. As you have seen, the request count may not be the most interesting metric. Sometimes it's interesting to see it here and to visualize it. But basically, when you have such a splitting, you can just select the metrics that you want to analyze, and the views will be automatically aggregated then. Here in my example, I switched over to the exception count because it can be interesting across the versions to understand how much exceptions are shown there. Is there any change in the behavior of the environment when we switch to a new build? This can easily be here in that case.
This is amazing because I just see that just by looking at it, the latest build on top, whatever that build was, has a clearly higher number of exceptions.
Exactly. Yeah. So that was exactly the point. And also what attracted my attention was here that peaks here that I wanted to understand a little bit better here.
Yeah.
And you can then use basically all our filter capabilities. So you can, when you just want to analyze a specific split here, just go either to make the filtering here or to go further and select our analysis tools. So I can now say, just show me the exceptions for this specific, for this specific version here. Yeah. I click on the exceptions analysis, and I have it now a completely filtered perspective on this.
And now you also have the sum, because earlier in the previous chart we saw the average per request.
Exactly.
Which is great because you still want to get trends.
Yeah.
And now you have the total. And this
you have the total. You can understand what is happening here. We have now the filters on top of it, so they're completely automatically adopted here. And you also get now a nice split by the different exceptions here. Because what you see in here before that, we had the exceptions as a whole. Now you can directly see which type of exceptions get thrown there. And now you can even drill deeper. So you can now, again, click on the analysis here, and you can go to the exception details for a specific exception. And this will lead you now to this aggregated perspective. So here you now see in the selected time frame how often was a specific message seen for an exception. This could also be, and would be quite typical. There's a different messages here. In our case, we're lucky. It's quite a clear one here, and you then can drill into your stack traces. And you can also then take a closer look to understand the affected requests if you want to.
And everything still in the context of that build. So if I recap, you started with a graph that showed me a particular version had a clearly outlier in the number of exceptions, a higher number. And then you drill down and say, okay, now show me which exceptions they are, what is the common, kind of root cause, and everything based on that particular version that you saw as an issue.
Exactly. And what is nice, as we have the split here, you can also remove them the filters or switch between versions here. Yeah. So yeah, I took this screenshots in advance because it was quite interesting, and I cannot bet on that we have such a nice exception pattern again.
Yeah, it's also great having screenshots. Is always good because we can repurpose it for blog posts and other things.
Yeah, exactly.
That's good.
So now let's jump over to a live demo because I also want to show this over there. And here I did something similar, but what you can see here is on the one hand side, I have now the response time here of the versions here. And when I take a closer look here by split by dimensions, I made some advancements here. So at first I look at the request names. So the requests that we categorize automatically by Dynatrace are now in advance for the version. So we can compare different requests if their response time is changing between versions here. And I made it a little bit more readable. I put here some brackets inside of it to make it more clear here in the visualization below of that. So you can here see, and one more thing, because in this environment, if I would have all the requests, it would be quite a lot. And I wanted to focus a little bit more which type of requests are important for us. So in this example, it's in Boutique app. We have defined specific types of requests that are interesting for us. And here I said, just show me the key requests. That's basically what we put also on the dashboard, but we can also remove this again and take a closer analysis here. But basically what you then get is, we see here, we have here two types of key requests. We have the place order and the get ads. And we have them in different versions running over the last 2 hours. And with hovering over it, we can also see what is the difference of it. And we suddenly see, hey, here, just half an hour ago, when I triggered my deployment with some issues here, we see that the place order with version 1.05, we have now suddenly a much higher response time here in that case.
This is really nice, especially now thinking, place order is already a nice API name, but if you think about different API endpoints, and you're deploying it then from one version to the next, you see either how it changes, or if you do canary deployments and you do things side by side, you immediately see the difference between version 1 and version 2, whether it's response time, number of exceptions, all the other metrics that is shown. Yeah,
exactly.
It's pretty powerful.
And we can for sure jump directly now here to the analyzation. So we see here on the one hand side what's happening here. What I want to see, we have the response time here, and we can also here do some other switching here. So what is interesting here in that case, for instance, would be the CPU time. So we see here, for requests in that version, the CPU time was now going up. In that case, I know it because I built this issue by myself inside of it. But this is a nice example where you can then already do an explorative analysis here and do a very quick switch between of them.
One more thing, you have the filter here on the key requests because you marked certain requests as these are the ones I'm interested in. Now, if I would be, let's say, the responsible developer for the get order, I could also say filter just for get order.
Yeah, exactly.
Right? You can do everything on it.
And we have here now, for instance, when I take a look, we have multiple requests on it, but we want to stay at the key requests on the one hand side, but we also see that this is such an outlier that it's quite obvious what is happening here.
Yeah.
And when I now want to analyze just this specific request, the place order request in version 1.05, then we get all our code level data that one actually is also automatically collecting and put it in context with the distributed trace. So I can now drill deeper from here. I can, if I want, jump directly with PurePath. I will do this a little bit later. I want to do it in an aggregated way. So I directly want to jump on the method analysis because we see that we have more time on the CPU here in that case. So let's jump directly to the method hotspot. And that basically gives us now from exactly the request, the distributed traces that have entered our system in version 1.05, the specific request place order of our checkout service here. So that's important for us. It's a key request because place an order there is interesting. And we also see here on the one hand side, where do we spend our time? Now it can be interesting. Was this just introduced with version 1.05 or was this there before? I can just remove it. And now I see the full picture. I see, interesting, with that version, we now have also much more time in disk I/O and significantly more time in CPU time here that we can go deeper. And here we see also exactly what is happening here and where is all this time spent here. We have here obviously the place order handler inside of it, and we can go deeper here. And I did here quite a simple thing, a Fibonacci calculation that also writes something to the console out there, because I also wanted to not just have CPU, but also have some disk I/O here in that case, or system I/O. And it's quite helpful. Now we understand the Fibonacci, what is happening there, what was changed in this specific release, and we can go back in time when we want to.
And again, just to remind everyone, this is just happening because the only thing you have to do is install the one agent. The one agent is automatically instrumenting all of your processes, automatically captures the distributed traces, which we call PurePaths. And now, if the processes have the version awareness, meaning if we have the Kubernetes labels annotations, or in our case, the environment variables that you explained, then on every single distributed trace, we have the version information, and we can therefore do all the diagnostics specific to any version, compare it against each other, and find problems like what you've just shown here.
Exactly. So, and that's also what I wanted to show next. So now we can also jump now to the distributed traces that are here. I will now make the filter again. So select the release version here, and we have here the 1.05 to make this more readable here. And I can easily jump over to the PurePath perspective here of the checkout service. We see what is happening here. We can again remove it because it looks quite nice. Where you also can see then, it was happening here in that case. And we can also take a closer look to all the distributed traces. We see, this was one that had a specific release version and build version on it. And here we also have this quick analyzation. It shows it already, this picture that we have seen before, but we can also jump directly to the distributed trace, where we now see what is happening there when an order is placed. And we see all the information here in the PurePath that are basically feeding our aggregated analyzations.
Yeah, exactly. And again, folks, this is just what you see on the left here. It's an end-to-end distributed trace across different technologies, different environments, if you want to, fully automatically traced. Now we also support open telemetry, right? We also get all of your custom spans in. But not only is this great to look at individual traces, which depending on the use case is great, but what you showed is you start typically with an aggregated view. You want to understand trends, you want to understand if there are any hotspots that have been introduced with a certain version, and then you drill into it. Right? I mean, that's phenomenal.
Exactly. So what I have shown before was basically how we can use the multidimensional analyzers. But what you see here also is that you can, when you create a metric out of a multidimensional analysis, you can also put this metric directly to your dashboard. And I did this here. For instance, I put here the key request with the response time on it. So I see immediately what was happening there. And I can now also jump to specific services or to specific analyzation perspectives. So I can jump here, for instance, to the old versions, to 1.04 if I want to click on the service, and I will now get again
directly here
to a multidimensional analysis where I see now also what was happening there over time, and I can now analyze and slice and dice it again. So that's basically what is possible.
So this is new for me. That means on the dashboard, if you put a calculated metric that is based on a multidimensional analysis view, from the dashboard, you automatically get back to the ad hoc analysis.
Yeah, for the specific service. So when you have a split by service on it, you will come directly there and you can work on it.
This is really nice. I just had the partner asking me last week about, if I put metrics on a dashboard, what are my drill down options? And this is a major one.
And that's definitely a major one. Together with so we have here now the request name split, and when I think there are more requests on the service. Let's see. Now there are just this request on the service, but it's quite extremely helpful. Yeah. What is also nicely working, and this is basically the last part that I wanted to show, is it works not just in this single analyzation, it also works when we take a look, for instance, when we start at the very front end. So this is ahead of this microservice we have seen before. And when we take a look here for the service flow, for instance, to take a closer look, oh, here, how are my transactions flowing across my microservices? And when we take a closer look here on the checkout service and make a filter on it, we see what is happening here. And here we can now again use the version here, the release version, as a filter on it. Now take a look to the front end. Here in the front end, we have the 650 milliseconds average response time. And as soon as it hit the checkout service with version 105, we can press apply. We will see that it's now increased here. We have some effect on the front end, and it is going.
So you can see the impact of the different version of the checkout service to the front end response time to the end user.
Exactly, exactly.
This is powerful. So you can really specify the filters on every single node of your end-to-end service flow. And folks, for the service flow is really, it's again an aggregated view across all the distributed traces we have for a certain time frame. And then obviously again filter down, but you can now filter on individual, parts of the distributed trace. Yeah. It's really, really amazing what's possible then. Mm-hmm. You can really figure out how does a change in one backend service impact downstream services, upstream services? Yeah.
So that's basically quite nice. And I think, it's a little bit hidden, to be honest, but we have such a lot of properties. We cannot put each property on directly into the face.
What would be nice now if, I'm just asking, I have you as a product manager, I want to see the difference here between the different versions.
To make here really something to make a calculation.
Exactly.
That's our improvements we have on the roadmap for later here, but we are, as you can guess, the versions are just the first step to have this here, and we are moving forward here quite fast. Yeah. So that was basically what I wanted to show you in this performance clinic. Yeah. Any additional questions from your side?
So the question that I have, this is available right now as of 2/4, I believe.
Exactly.
Yeah. That means everyone, the only thing you need to do, and I know in the slides you have some additional links to documents, documentation to blog posts. Everything you need to do is install the one agent, get these DT release variables on your processes. Gives you two things. It gives you the release overview, meaning it actually shows you which versions are actually deployed in which environment. Right? If you go to the release overview, I think that's also really nice on the cloud automation. Releases.
It's not so rich in my demo environment here.
Yeah, but it's still whether rich or not. You see which versions are deployed in which environment belonging to which particular product. And then the additional thing is you also get the version information on every single distributed trace, and then you can do your ad hoc analysis, you can create your dashboards, you can share it with your team, you can create metrics, which means once you have metrics, you can do automated baselining, you can do alerting, and you can integrate this with, for instance, your quality gates and whatever you want. Wow. This is pretty cool.
Thank you. Yeah, that's quite some work here.
Yeah.
Great to be able to present it here.
Yeah. Hey, I think you do have in the end slides, I think you have a couple of...
I have a few things in the end slides. The resources, basically, most of them are referring to the Performance Clinic canary releases and versions. I will also add the link to the blog post, the latest on how to set this up. This is still missing, but I will then share it later on.
Yeah, perfect. Hey, with this, I want to say thanks. And looking forward to even more innovation here that will make life even easier for performance engineers, SREs, whatever they're called.
Thanks a lot.
Thank you.
Bye.
Bye.